Alright, I made a video, but about 8 minutes into it, the sound just went so I'm making it again. I thought I'd tell you about my ideas to conquer the universe, or actually to mine near-Earth asteroids. Like Musk, he wants to colonize Mars. I want to mine near-Earth asteroids. And he's going to need a lot of fuel to go to Mars, so maybe I'll be supplying him with the propellant or reaction mass. So this is my idea. This is an old drawing. I've actually come quite a ways from this, but it'll give you an idea. I call this blue space. That's from science fiction. There's actually these 3 books called The Three-Body Problem. Well, the first one was The Three-Body Problem. It is the best science fiction books I've read in a decade. Maybe the best I've ever read. Really good. I really recommend it. And it's written by some Chinese guy, and I can't even pronounce his name. So anyway, I call this blue space because there was a spacecraft in those books called the blue space. Now look, see right here? There's this little cross. Those are fuel tanks. Now, they're not like the rest of the fuel tanks. They're made from polyamide and fiberglass. Now, polyamide is the most radiation-resistant plastic that we have. So, you know, normal plastics, you leave them out in the sun, they break down. Well, in space, the sun's even worse. So the reason those tanks in the center are different is because they're insulators. Okay. Now the rest of the tanks, these long things here and on the other side over there, those are propellant tanks that are just welded together. Okay. And they're made of magnesium, but they have a cladding of copper on them. If you just use magnesium, you'd get magnesium oxide, and you'd have electrical problems. Because magnesium oxide is an insulator, but copper oxide's not. Okay, and then these things here, those are cables. They're the same thing. They're magnesium cables with a copper cladding on it. Okay. Now, on these things, this here is probably the positive pole, and then these ones are the negative poles, and then these are insulators to keep them from shorting out. And between these cables, you take big rolls of solar panels or solar rays, and you could use Kapton, that's what they use a lot, but I'm using screen wire because Kapton will break down from sunlight. And then they're just clamped onto these cables. So this whole big, huge area here and here is all solar collectors. And then these things are all tanks, and they're filled with reaction mass. Ammonia would be ideal. You could probably use hydrogen, but you'd probably have to just pressurize it at low pressure, so you wouldn't have a lot of density. But you could even use water. It wouldn't matter. It wouldn't be the most efficient fuel, but you could use it. And then out here at the end, or sticking out the side somewhere, would be arc jets, which would just use an electric arc to heat up the reaction mass, and then it'd be expelled out the back. You can get very good specific impulse that way and still have decent amount of power. Okay, now this little thing here, this is the living quarters. Okay, I think that's about 12 meters across, just to give you an idea of the scale of the whole thing. So these are like 12 meters from one side to the other. And they are 26 inches thick, the walls. I did some calculations, and if you want to reduce the radiation level to the level at 15 kilometers up, you need about 26 inches of magnesium. Magnesium is the best material to use because the higher the density you go, you know, like if you use lead, for instance, you will have this, like a cosmic ray, which is something like, say, an iron nuclei traveling close to the speed of light. It's going to hit that lead, And then you're going to get all these lead particles flying off. And they're going to be like, instead of getting hit by one bullet, you get hit by 10, you know. But the lower density, it helps you, okay? And so the dividing line is aluminum. Aluminum's kind of neutral. It doesn't help you, doesn't hurt you. But you get lighter than that, it helps you, and you get heavier and it hurts you. And magnesium's the only practical metal that's lighter. NASA's looking at plastics, but like I said, that stuff's going to break down. But, you know, they don't think long term. I mean, otherwise they would have stayed on the moon if they were thinking long term. So anyway, these things are 26-inch thick magnesium walls. That reduces the radiation level to 15 kilometers. And according to the FAA, if you stay below 15 kilometers, you don't need to worry about radiation. If you go above it, you have to wear a badge and a radiation detector. And whenever there's a solar flare and the radiation levels go up, you have to bring the plane down below 15 kilometers. Obviously, you can't do that with this thing, so I just want to have it thick enough to protect them. And that's one of the big problems with a lot of plans of, you know, space, is nobody's thinking about radiation protection because it's really inconvenient. Making walls this thick is really inconvenient. The only way to do it is just to make the whole thing huge. You know, I mean, aircraft carriers have a hull that's 1 foot thick solid steel, but it's not a big deal because the aircraft carrier is huge. You put 1 foot steel on a small boat, the boat would sink. So the only way to practically get out beyond the Earth's protection for radiation is to get big. But it kind of makes sense. If you want to cross a river, you just need a pair of boots, maybe to keep your feet from getting wet. If you want to cross a lake, you need a small boat. If you want to cross an ocean, you need a bigger boat. Well, space is the biggest ocean of all, so you need a really big boat. If you try and do it in a little itty bitty boat, you know, people have crossed the ocean in a rowboat. It's a stunt. It's not practical. It's not something that people do every day, you know. If you want to cross the biggest ocean there is, you need a big boat. So this is a big boat, but still, it's as small as you can make it. This has a crew of something like 40 people, you know, and I think it'll carry 50 with some passengers. So that's any smaller, and it just doesn't work. It's like trying to cross the ocean in a rowboat. Some things just got to be big. Okay, so then how do you get the tanks up there? Well, that's what this is. And this is where I screwed up on the last one, so I'm hoping I can make this a better video. Okay. God, I'm already on 8 minutes. Okay. Let me see if I can kind of center it here. Come on. Well, hopefully you'll be able to see that. Okay, let me get this out of here and get over to here. Okay, this is the Rocinante. That's from another science fiction. It means workhorse, which is a good name because that's what it is. It's a workhorse. It used to have a nozzle, but I sneezed and somehow erased it, and I cannot figure out how to get it back. I tried undo, but it didn't help. Okay, now in this thing, let's get a better view of it. This is the big copper-clad magnesium fuel tank, or propellant tank. And see this inside? This is concave here, and this is convex. This is a hemisphere. And right here's a little notch. Now, you can't see it, but I think I can probably show it to you. There. See that? Lower it down here. See that little notch right there? That little notch fits down here, this edge here. So you put them together. They just go together, and then you weld them together. Okay? You have to be a little careful with magnesium because when you melt magnesium in a vacuum, it actually vaporizes. it won't stay liquid. So you need a teeny bit of atmosphere to keep it from vaporizing, but it turns out to be about a half a psi. So you basically need to have a shielding gas to shield it from the vacuum. Sounds weird, but that's just the way it is. Okay, now let's go back into here. Now, this here is where the solid fuel. It's a hybrid rocket, and it uses a unique propellant, which I'm not going to mention, but it's really clever, and nobody's ever thought of it before, and I bet you NASA wishes they had, but they didn't. I did. And then these are smaller rocket engines here. I haven't finished the drawing yet. The nozzles are gone. And this is propellant for landing. Now this is the propellant that's used for the main engine, which is here in the center, and then the main engine gets ejected, and then you run on the secondary engines over here. And they carry it on into orbit, and then you use these engines to deorbit it. By the way, when you're in orbit, first thing you do is you lose the tank right up there, okay? So now this is your spacecraft. Up here is the living quarters. There's 5 little cabins, okay? And there's also a little tube so you can go up to here, this upper area, which doesn't really have much up there. There's a carbon fiber nose cone, carbon-carbon nose cone, and this allows you to get onto the inside and repair it if it's damaged. And you can store stuff up there. It's kind of like having an attic, you know, but it'll get warm on re-entry, so you don't want to store your candles up there. So anyway, and these things, these red things, those are ejection pods. Hopefully it'll be possible to eject even at altitude. Now this whole thing is made of a magnetic alloy. I mean, it's made of a real high strength steel, except it's not really a steel. It's kind of hard to explain, but you can wear magnetic boots and stick onto it. Now this outside, this gray area, that's a high temperature alloy. It's sort of a heat shield, okay? Now these little bumps here, that's where the berths are. Let me go down to here. You see there's 5 little cabins above, and there's 5 little berths, and they kind of stick out in between the 2 hulls. There's 2 hulls here. And then this is a little passage to get up above, up into the attic, if you will. And this is down here, this lower area is where you do most of the running of the spacecraft. And this area here, there's a hatch here, and this can work as a lock-in, lock-out chamber. So you can lock out and go out and come back. Now let me go down. Yeah, these are the tanks for the liquid part of these rockets. There's also a whole bunch of small maneuvering jets all over the place, which I haven't drawn yet. Anyway, if you go down here, you can see there's 10 of these. This is the second stage, and also the landing rockets and the deorbiting rockets. And then you have 5 of these ejection pods and 10 propellant tanks. And then this is the heat shield out here. So that's that. And then there's the nose cone, which takes the worst of the heat on re-entry, and that's the propellant tank. That is the main job of this thing. It'll carry 5 people, but it needs 2 people to run it. So you can carry 3 passengers. You can carry this big, huge tank up here, and you can carry a small amount of cargo just wherever. It's not meant to carry a lot of weight. Mostly the job of this thing is to carry this huge tank up there and leave it up there, and then come back and get another tank. But it'll carry people up there. Also, this acts as a rescue craft. It has a lot of space, so if something goes wrong with the big ship, you can bring a lot of people back down again. Actually, that would just be in an emergency. Under normal circumstances, you wouldn't want more than 5 people in here because you only have 5 little ejection pods. But in an emergency, you could probably put in 25 people in this thing and bring them back. Okay, so let me turn it forward.